Hello everybody, welcome to lesson number 13 in the Python tutorial series. Today we're going to be looking at the difference between a local and a global variable and introducing a couple key terms like the global stack. And it's one of these concepts that I think is fairly difficult to understand until you get further along into programming, but it's also really important. When you start creating your own user-defined functions and executing your own user-defined functions, you're going to be creating local variables. And when you're trying to program, say, like a video game or something, let's say you're going to write a function that adjusts a character's health. They get hit by a sword and they had 100 hit points and they're going down to 90. You might write a function that takes their health and reduces it by 10. But if you don't know the difference between a local and global variable, you can do things like you pass in a variable, pass in their health, do a bunch of manipulation to it, and unfortunately when the function is done executing, none of your numbers have changed and you'll find yourself sitting there scratching your head trying to figure out why. Local and global variables do take a little bit of practice, but you will get it eventually. And we're going to be using something called the Python visualizer for this lesson as well. The Python visualizer is an external website that I really like to use that helps me debug my programs, even some of the more complicated programs. It's a web address where you can copy and paste your Python code and then execute it line by line. In addition to executing it line by line, it will keep track of all the variables you've defined, whether they're local or global variables. It keeps track of changes, so it's a really useful tool for debugging programs and figuring out exactly what's going on. So we'll be pulling that up as well, and you'll be able to follow along with me on that website as well. So that's the topic for lesson 13, local and global variables. There is not going to be a challenge program this week because this isn't a lesson that works well in isolation. You'll be using it with some of the more advanced concepts. In fact, we're coming up on our next project. Lesson 14 will be about nested functions and time, and then we're going to be into our next project straight away. So let's go ahead and get started with local and global variables. Okay, so you can see I have my window configuration changed just a little bit. The reason I did that is I've got Google running in the background. In order to follow along with today's lesson, we're going to take a little bit of a diversion and we're going to go to a utility called the Python visualizer. So you're going to want to pull up a web browser, and the easiest way to get there is just to do a Google search for Python visualizer. And when you run that search, you can see it's the first one that pops up. www.pythontutor.com/visualize.html, and I'll put a link in the video once it gets posted to YouTube. When you click on that link, you get to a screen that looks like this right here. It says write your Python code here. We're not going to write the code directly into the Python visualizer. What we're going to do is we're going to write our program over in our programming window as typical, and then we're just going to copy and paste it into the Python visualizer and see how that works. So let's pull up our Untitled window again. Let's see, or the Python shell. There we go. And let's write a really simple program that everyone here should be familiar with. And so what we're going to do to start off is we're just going to import random. We're going to create a couple of random numbers. And what we're going to do is set a variable x equal to a random number between 1 and 10. Random.randint. We're going to set y equal to a random number between 1 and 100. And we're going to set z equal to a we'll set z equal to the sum of x plus y. And then we'll print z. And then we'll do something different. We'll take z and we'll reassign it the value of x minus y and print z again. This should be a fairly straightforward program for anybody who's followed the tutorial up to this point right here. We're just going to create two random numbers, add them together, and then we're going to store all of this information in different variables. So if I were to execute this program right here, save it as my test.py as normal, I look over here in my window on the left, the Python shell, and I see I get 23 and 17. In fact, what I might want to do is print x and y so I can see what those two values are and execute this program again. I can see the value of x was 8, the value of y was 96. 8 plus 96 is 104, 8 minus 96 is negative 88. So I'm getting the expected output over here. Now, while this particular program is very easy to follow, getting used to the Python visualizer at first can be a bit of a challenge. I didn't like it at first. I had some trouble looking at it. I said, well, I'm running these programs just fine. I understand what's going on. And it's not until I made bigger programs that I saw the value in the visualizer. And it really does help keep track of variables, and it does a very good job of allowing me to explain the difference between local and global variables. So let's go ahead and pull up the online Python tutor or the Python visualizer. And I'm going to take this code on the right, and I'm going to copy and paste it into this box right here. Once I have the code set up, I'm going to click the button near the bottom that says Visualize Execution. So I've got this screen right here, and the window on the top left has a list of my code along with the line numbers. So this is a 9-line program, and it's got a little red arrow that says when I click the next button, that line 1 is the next set to execute. So it hasn't executed yet, nothing's run yet, but that's the line that's going to happen next. Over here in frames and objects, this is where the Python visualizer is going to keep track of our variable values, and there will be a window down here. When it prints something, it will simulate what's printed on the screen down below where the code is. So let's click the forward button, and we can see the first thing that happened is it executed line 1, and now in the global frame we have access to the random module. We don't have access to the random module until we've imported random, and now this visualizer lets us know that random is accessible because we've imported the random module. The next line of code is going to assign a variable x a random number between 1 and 10. So when we execute that next line, click forward, we can see the random number we got was 9. There's now a variable x that holds a value of 9 in this global stack. We're now going to get a variable y and set it equal to a random number between 1 and 100. So I click forward. We see we have generated a y value. Its value is 76. So if we call x or y, we're not going to get any sort of error because x and y exist in the global stack. Our next line of code is going to print x and y. When I click forward, the program now outputs 9,76, which is the same thing it did when we ran the program in the shell. So the next thing it's going to do is initialize a new variable z and set it equal to the value of x plus y. Well, we know x is 9, and we know y is 76, and they're both variables that are in the global stack. So when we execute this, z gets a value of 85. Now the thing to note here is the program hasn't outputted anything. We haven't done the print statement yet. The print statement hasn't executed, but the z variable now exists. We know it's equal to 85, even though we haven't printed it yet. Z is still 85, and of course we're going to print it next. So the next line executes, we print 85. Now we're going to set z equal to x minus y. And if you watch over here in the global stack, when we execute the next line, it doesn't add another copy of z. It takes the same z, because it's the same variable name, and just reassigns it a new number. Now z points to a value of negative 76. We click forward, and it prints that negative 76. Our program is done executing. The forward button gets grayed out, and this is the output we could expect to have from our program. Of course, if you remember back to the Python shell, it is the exact same output that we got, albeit the numbers are a little bit different because they were randomly generated, but it's the same output. By using this tool, though, you can step through your programs one line at a time and make sure that numbers are being assigned as you would expect and variables are being created, and it can help you stamp out a lot of syntax errors. For example, if I come over here to my code and instead of doing x plus y, I do x plus c. Let's copy and paste this. I'm going to click my back arrow and I'm going to copy and paste that new line of code with a reference to a variable c, and I'm going to visualize execution again. Now, it still looks the same, and when I import random, random gets imported. That's perfectly normal. I get my variable x equals 9, y equals 76. I'm going to print x and y. That executes perfectly fine, but now z equals x plus c. When I click forward, I get this name error, c is not defined. The reason I'm getting that error is because I'm instructing Python right here to go to the global frame and look for a variable c. It's going to look through this list right here, and there is no variable c. There's nothing in the global frame named c. It can't pull a value from c because it doesn't exist, and that's where my name error comes from. C is not defined. So that's a little bit about how the Python visualizer works. Okay, so let's go ahead, and I'm going to hit the back button, and I'm going to go ahead and clear my Python visualizer window. And I'm going to erase my test program. I'm going to write a new program. It'll be a little bit more complicated than what we did previously, but still something that should be very second nature to you, or at least make sense to you. So this program is going to have some of our user-defined functions. In this case, I'm not going to use any random numbers. I'm just going to define a function called add that will take num1 and num2 as arguments. I'm going to forego adding comments here. You can put comments in your program, and the Python tutor handles it just fine, but for purposes of our example, I'm going to skip commenting here, and I'm just going to return the value of num1 plus num2. A very simple addition function. The next thing I'm going to do is I'm going to define a function called subtract, and as you can imagine, it will take num1 and subtract it from num2. However, we're going to write this program, or this function, a little bit different. In fact, we're going to do it in a very inefficient manner. We'll still get the same result, but what we're going to do is we're going to take num1 inside of the function, and we're going to set it to a value of x. So x becomes equal to the value of num1, and y will become equal to the value of num2. We are then going to initialize a variable called final num, which will be equal to the value of x minus y, and then we're going to return final num. Now when you look at that right there, there's a way more efficient way to write that function. In fact, you can do it the same way that you did the previous function, return num1 minus num2. But we're intentionally creating some variables in the subtract function. It is not an effective way to write this function. You should be a lot more efficient with yours, but for our example, this will definitely serve its purpose. Now what we're going to do is we're going to create 4 result variables. So I'm going to have result1 equal to my add function, and we're going to put in the values of 2 and 4. I'm going to have result2 equal to the add function, passing 4 and 8 as parameters into the add function. I'm going to initialize a variable result3, and that will access my subtract function, subtracting 10 minus 4. And then result 4 will be equal to my subtract function of 15 and 8. Now let's pull up our Python shell window and execute this program outside of the Python visualizer and see what we get. Absolutely nothing. There are no print statements here. The return statements, while these functions are being called, we're taking the results and storing them in variables, so nothing actually prints in our shell. Now I could type result1 manually and see that that equals a value of 6. And of course 2 plus 4 equals 6. I can type in result2 and see that I get 12. So this definitely executed. But this is what the visualizer is so good at. If this were a more complicated program, I would look at the resulting shell execution and I see nothing, absolutely nothing happened. I'm kind of on my own to trace what happened in this program, and I might not be able to do that with more complicated programs. So let's get the online Python tutorial here, and let's go ahead and copy our code over there. So my code shows up here in the window. I click Visualize Execution. I've got my code sitting right over here, and let's see what happens. So the first thing you'll notice is there's absolutely nothing in our global stack. I click forward once, and in our global stack, there's now a function called add. This means from this point forward, I can call add. Now you'll notice the next line of code that's being executed is the next block. This return statement is completely ignored. When we define our function, all we're doing is adding the add function to the global frame so it can be called later. We can tell now that Python has got a function called add that's going to take num1 and num2 as parameters. In fact, earlier in the video I might have switched up arguments and parameters. These are parameters. So the next line of code that executes is this define subtract statement. I click forward, and I can see now subtract is in the global frame. It will take num1 and num2 as parameters, and everything under this function, x, y, final num, return final num, none of that actually executed. All it did was define the function so it could be called at a later time. So the third step, we're already down to line 10. Much of this program has been skipped. So now we're going to have to initialize a variable result1, and we're going to add 2 and 4 together. So what happens is we want to initialize a variable result1, and it's going to have a value of our add function 2 and 4. But in order to get a value, we have to run through that function. Result1 isn't worth any value yet. We have to run the function and see what the value is going to be. So now it's instructed to go up to this add function and run it. So it bumps up here to the add function and says I'm going to return num1 plus num2. Now what you'll notice is Python is not in our global stack anymore. It's actually in this add function. Now our global stack still exists, add and subtract still exist here, but Python is looking specifically at our add function. You can see 2 variables are accessible in our add function, num1 and num2. Num1 is a value of 2, num2 is a value of 4, and it got that from the arguments that were passed in at the time of the function call. So now we're going to return num1 plus num2, and our function has a return value of 6. That means when this function is done executing, it is going to return a value of 6. Essentially, result1 equals 6 because that's the return value of the add function. Now that that function is done executing, we have a variable result1 in our global stack that houses a value of 6. The next line of code, result2, is going to access the add function again and pass 4 and 8 as arguments into that function. We click forward. Python pops back up to line 1 because that's where the add function is at, and we can see we are now in the add function, only this time around num1 equals 4 and num2 equals 8. We hit forward, it's going to execute the return statement, it's going to return a value of 12, result2 takes on that value of 12, and you'll notice now that just like it did the first time, though I didn't point it out, that add stack is gone. Num1 doesn't equal anything, num2 doesn't equal anything. If you were to try and call num1 and num2, you would get an error in your program. But now we have 2 variables established, result1 and result2, that came from this function right here. When we step through the subtract function, it's going to be a little bit more complicated. but it's going to start out just the same. Python is instructed here to access the subtract function, which it knows exists. We can see it here in the global stack. So it pops back up here to where we define the function, and it says, okay, num1 equals 10 and num2 equals 4 because that's the arguments I was provided. The next line of code is going to create a variable x and set it equal to num1. Well, num1 equals 10, so x equals 10. And in our subtract function, we've created an x variable. Y is set equal to a value of num2, so y equals 4. And then final num is equal to x minus y, which is 10 minus 4. So final num gets a value of 6 right here. And we have a return statement that accesses final num. Well, since final num is 6, it's going to return a value of 6. And result 3 will be equal to a value of 6. It's the same thing the add function did, but look at all the additional calculations we had to do inside the subtract function. But once we get our return value of 6, that subtract function goes away, and there is no more x variable, there is no more y variable, everything disappears, and all that remains is the 6 that the subtract function returned. We're going to do that again with result 4. Result 4 calls the subtract function. It passes a value of 15 and 8. The next line of code sets x equal to a value of num1, which is 15. Y is equal to a value of 8. Final num becomes 15 minus 8, which is a value of 7. It returns a value of 7, so result 4 here is going to take a value of 7. The function is now done running, and Python can forget everything that happened in the subtract function. So now we're looking at result 4 being equal to a value of 7, but what you'll notice is that the program is done running, nothing was printed to the screen. The fact that nothing was printed to the screen doesn't change the fact that result 1, 2, 3, and 4 all exist, and our access to the add and subtract functions also exist. So hopefully that section wasn't too slow and boring. I just wanted to make sure that everyone had a good idea of what was happening in the background, even when things weren't printing. We are going to stop lesson 13 right here. We're going to take a break, and we'll come back with lesson 13.2. Lesson 13.2 will use the Python visualizer to give you an example of local and global variables and how they'll impact your program running. Now, nothing we did today should be any new information, so my apologies if it's a little bit boring. It's an important topic. You can't just ignore it, but I also understand this is kind of a little bit dry. So just make sure that everything we did today made sense to you. As always, if you have any questions, you can leave them in the comments. If you need any help with anything, I'm definitely here to help you out. I appreciate the new subscribers that have subscribed to the channel. It's great to have you along. So if you need anything, just let me know. Otherwise, we will continue with lesson 13.2 on local and global variables here as soon as I get a chance to record that and post it. As always, have a great day, and thank you very much.